live a little prematurely, didn't I? I forgot to refill my water. Oh, Discord. Who'd have thought it'd make a noise? Who thought Discord would make a noise? Another noise. Oh my goodness. Browsers goes crazy. Browser goes crazy. Beautiful. I love it how Twitch doesn't upgrade the thumbnails. Like it stays with the same thumbnails for like the next month or two. And it doesn't reset. It's my favorite. It's my favorite. Okay, this is what we're gonna do. We're gonna do a little something here. We're gonna do a little something. I'm gonna get some water. We're gonna get some water. I wanna light this candle. You know, just for a little bit. And I don't know. I really have no idea. Usually I have a plan. I want to do stuff. I usually have a plan going into this for what I want to do. Right now, I just kind of go in any direction, to be honest. We can do some character design. Or not character design. I'm thinking mostly on level design. Thinking about how we're gonna have the player mechanic work out. And what's just the vibe of this first like intro stage you want to do? It's not gonna be like the final thing. I just want to have something to test out the visuals of how our game is going to look. And yeah, some stuff related to that. I might have to do some resizing things, but we'll address things as they come. I want to think about what kind of environment our character is going to be occupying, like visually, and go from there. I think about going more sci-fi route. Going a more sci-fi space route. I've been kind of thinking about space more lately. So we have some cool topology, but then have some like crazy weird thing that you wouldn't expect to see. Like some big astral architecture. It's like invading this planet in a bunch of different ways. Like maybe the planet has like layers to it. It's like these are like the slums. Not slums, but a lower level. You have like some space elevators going up or something. Excuse me. My stomach's a bit upset for some reason. And you have things further over there. Have some foreshortening going on. Just indicating how massive the structure stretches out for. It'd be kind of cool to have some space be revealed though. Like if there's chunks missing or something. Maybe it's designed to be like that. So you can have like a hexagonal hole. And then something peering through to this other future level. That could be pretty cool. Let me, 1 second. I'm also realizing something that I need to add to the engine, which is like a preview mechanism to see the current tile you have previewed. So when you're in insertion mode, it should like display the tile. Like right now, where's Sea Lion? if I were to go into editor, you would see that I have this cursor here, and I could like place things, but I don't know how they're gonna look. Like I assume they're gonna be aligned to this grid, but maybe not, you know, like maybe I don't want to do that. Maybe I instead want to like see how far is this gonna look good, where back here it's gonna look good, like oh, whoops. Oh, can't go back yet. Or I think I could before. But you get the idea. I need to have like a preview thing that shows the current tile and how it's going to look over there when you finally... Because maybe it looks too small and you want to make it... should be closer or something. I don't know. I should probably also look at like scale factors too. Yeah, like I can navigate assets this way, but maybe have like a thing where I can change the size of it. I don't know. Anyways, without further ado though, light, beautiful. Okay, let's place this fire hazard somewhere. It won't ignite. I guess before I get into things, I should probably start working on getting some water. Strong smoke. I can't even smell the hickory. The redwood, I just smell heat. I get some more. Okay. Sweet. Okay. I guess without further ado, let's just get into it. Actually, I really like that idea of having like a temporary indicator that shows where on the in space your tile's gonna be placed. So let's quickly do that. I don't think it should be that crazy. Editor, controller. I think what I may want to do is that when we go into insert mode, enable insert UI. I'm gonna replace the cursor icon with a new, or maybe we just have a new icon. Maybe that's just what we do. What does the sprite object contain again? Contain stuff, right? You contain yeah, all the basic essentials for a thing to be visible. Transform, mesh, animator, if that's applicable, and then so on and so forth. Okay, sick. And then texture info. Yeah, it's not tied to that. Well, arguably it should be tied to that, but we'll do that later. Object preview. Or actually, where's the because for the mesh you want to change the size of this. I'm trying to remember how we do stuff here. So enable UI, enable insertion UI. We iterate. Session enable shader. Yeah, this iterates this build. Okay, this enables the view for the tile window, the little tile palette on the top. Yeah, and this is where we issue that command. Okay, interesting. Okay, and this the selected texture. Oh, that makes life easier. So we can do render module, or I guess session render set texture, and then what should we use? We use. Hopefully, this is a quick fix, and then we can do some like concept thing. Set texture. Yeah, actually, I wanted to play around with some stuff today. I wanted to play around with some like new code things that I learned about today, but I don't think my brain's in a state to try out new things. So we're just gonna work on things that I'm at least somewhat familiar with, which I should be hopefully familiar with. I did write this, but yeah, it is what it is. It is what it is. Okay, so let's get this texture going. We have selected texture, and we need to have the render ticket, which is from the camera. What was it? Yeah, camera. Oh, cursor. My bad. Cursor texture. Oopsie. Or do we need the render ticket? Yeah, we do. I'm gonna do like a big refactor. We're gonna make this like each render ticket acts like a module. Like you can interact with the module directly. Like have the tickets have a pointer to the module that it's a part of, and then let you be able to do operations like this on it. Okay. I don't know though, we'll see. Set texture, cursor, render, selected. And then here instead we do because I believe we store a pointer and we set this back to cursor texture. Okay, sweet. So now, if I understand this correctly, it should work. It should be fully opaque, though. It should look fully opaque, not transparent, which is no bueno, but for right now, we'll work with that. And from there, the size is not going to be correct. That is the thing. We're going to have to adjust the size later. But let's just see how this works. So we go to insert mode. Yes. And yeah, as we see here, the size isn't correct. It's being sized down to 64 pixels, but that's fine. It's still nice that you can like see where the things are gonna be. Yeah, that's pretty nice. Okay. Let's fix that texture size. Let's just do that. And I think it should be pretty straightforward. I think we should have to go to session transforms, set scale, cursor dot transform, and what's the new scale factor? It's going to be selected dot. I believe I have size in here, right? Size and pixels. Yep. What's the issue here? May not be initialized? Who cares? I know what I'm about, son. I'm gonna know what I'm about, son. Sass me, boy. Okay, we have cursor. Texture. Cool, and now this should make it accurate. And then opacity I'll deal with later. So now we go to insert mode and hey, now we have what we're gonna place in the accurate size. Beautiful. That's not accurate. That's humongous. Oh, I guess that's a pixel accurate? Are we not updating the size? Oh, we're not updating the size. Oh, I did something wrong. I did something bad. We need to be updating the size of the cursor every time we scroll through. So, yeah, here we have tile indices, blah, 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 blah. Set texture, insertion mode texture, and then like was here, we're just gonna yoink. One second. No. This it is actually accurate. Yeah, like this size is accurate. So I'm not sure why the player sprites are so big. That strikes me as a little bit odd. Not going to lie. This is super nice. I can just... Okay, I don't know why this is not picking up. I'm deleting these guys here. Need to work on that. Let's see what my console is telling me. Tile not found. That's not great. That's not great at all. Oh well. Yo! Why is that happening, buddy? Okay, it looks fine now. It looks reasonable. Yeah, we're gonna work on collision sometime soon. It's not great, but it's good enough for what I want to do. It's like Game Maker level collision detection, like the way I would have done it in Game Maker. Pretty much. But it's just a really duct tape solution. But hey, at least we have our selection working largely as intended. Either way, I consider it an improvement. Oh wait, let's test to make sure that the cursor goes back to the pipe. So you see how we have this cross thing here? This little cross texture. And then we go to insertion mode and it goes away. If I go back to, yes, it works. It works. Yep, visual mode works. We're gonna have to do selection at some point, but that's not what I'm gonna be doing right now. That's not my main concern. We'll deal with that when we deal with that. Where's my phone? No. Oh well. I'll put on my headphones. I actually want to hear to see if everything sounds correct. Just to be sure on the safe side. Because sometimes I feel self-conscious. I'm not sure how good my audio is actually sounding. You know? So we gotta verify. Oh yeah, I'm not hearing my audio correctly. But it could be because I'm using a really bad a really bad adapter for a lot of this stuff here. That could very well be the reason. Okay. So we have this working. I haven't played around with transparency in all honesty. We just discard stuff, but I think for 2D sprites, it should be fine to have like, I don't know why these are so huge. I don't think they're sized up. Oh, it's a sprite sheet. So it's the size of the whole sprite sheet, even though we're only showing the actual segment. Oh. That's interesting. And needs to be fixed. So when we set the scale and enable insert UI, we need to divide this selected size by there's frame count, that's not accurate. We can do columns. Yeah, we'll do that. And now when we do this, we should see accurate. So if I got, yeah, now these should be correct. Now let's see if it actually works when we place it. No. No. And no. Not working. Okay, the create tile, that's simple. That's just an issue with the create tile function. That's something I neglected. Which is size, should actually be size divided by what? Size divided by, where's the texture information? Columns, there we go. Okay, now this should be 1-to-1. That should be 1-to-1. So now if I go to insert mode and we get really humongous, so nope, still wrong. What's going on? Oh, in the creation mode. So okay, yeah, and then the command itself. So I imagine if we place these down, they're gonna look humongous here. When we actually go into play mode, they're gonna be normal. No. They're actually just still humongous. Okay, that's not great. Collider. Okay. We shall deal with that. Create tile command. What do we have going on here, buddy? Tile textures, animation. Quest quad. Reserve animator, play animation. Request transform. Texture columns. That should fix things. I believe that should fix things. Yep, now it fixes. We play. We should also fix the colliders, shouldn't we? Where is that collider at? Where is that collider? Yeah, we're gonna have to centralize this at some point. Right now we're doing like a bunch of duplicate code. But I know there's gonna be a way to simplify things a bit more. Either way though, this should be fine. This should be fine. I kind of add more UI to this. He's still stuck in there. Fixing the tile creation, and I believe the tile command. Unless I didn't. No, I didn't do here. Yeah, we're using this a bunch, so we're just gonna. Yeah, just make life a bit easier on us here. Cool. And then let's pause for the collider here. What am I missing? There we go. Okay, we should be able to play it, and this should work, I think. So we do you, and maybe why not you? Yep. Now we have correct colliders. Very nice. Very, very nice. Very, very nice. Not animated though. It should be animated just at a slow resolution, but yeah, we'll deal with that. Okay, sweet. So level design, ideas. I don't want to exit. I don't know why you got that notion. Trying to think of what this is gonna be here. I was like the idea of like orbital elevators, even though they seem wildly impractical for any kind of use case. Oh, there's something that's always been kind of cool about that though to me. I don't know, what can I say? Man with rich tastes, right? Dun, 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 dun. Don't like the look of that. What does this planet even look like? Like if we have the idea of like multiple shells, we get like different stratifications in different places. So you have like one like shell like this covering one level, and then have another shell covering that. I'm not sure what will be the utility on this though. It'd be kind of cool though if this is like a Dyson sphere kind of structure. Oh, that'd be pretty cool actually. Having the game taped like having this intro level take place on like a Dyson Sphere utility outpost, like the equivalent of like a space oil rig, except instead of oil, it's like solar energy. Of course, you're gonna let some leak out, I guess, so other planets can still get some of the sun. But actually, would you want to do that? I guess if you have the sun here, and you'll see your fictional planet is like over here, all that's really needed for your planet is on like this sphere. In fact, really, the only thing you really need from the is like from the only thing you need from the sun is like comes from this little region here. If you want to be really specific, you can be like have it like here. But then you may ask yourself, but we don't say fixed like that, you know? What if our orbit is like this, you know? What then? Because then you're gonna move outside of that Goldilocks range. But what if like the Dyson Sphere has like an aperture, and we can control its rotation around the planet, around the sun? Because clearly in the fictional future, there's got to be some way to do that. You don't have some super thin structures to be able to do that, but that way as it rotates, so does the Dyson Sphere. As this goes around here, that way it rotates, so you can... I've been saying Dyson Sphere. Is it Dyson Sphere? I'm pretty sure it's a Dyson Sphere. Let me Google this. Yeah, megastructure that encompasses a star and captures a large percentage of the power output. Yeah. So you don't need to have like fully eclipsed. I mean, a lot of the ones they have here, there's like a lot of... It's much more practical than rotating the whole thing, but hey, we're operating in the realm of fiction, right? We're operating in the realm of fiction, so why not have a little bit of fun? Why not have a little bit of fun? Yeah, this is what I'm thinking, like a structure that captures most of the sun's output, but then has an aperture or an iris that allows some of the sun to hit whatever planet you want it to be looking at. I always wonder though, like how do we transport that that energy? No, not AI mode. I don't want AI mode. How would energy be transferred? Hypothetically. Dyson swarm. Yeah, how do you transmit energy? How does one go about doing that? Yeah, like I feel like it says microwave beaming, but that's exactly what I was thinking. I was like, there's got to be some energy lost either through, I mean, likely it would mostly happen within the atmosphere, right? Because that's where the most particles that it can interact with would exist. Like a desert. Interesting. Microwave beaming. That's pretty cool. phase array transmitter, power input, module output. %, conversion to microwaves, beam capture, 85% efficient. That's pretty cool. Okay. So technology exists, microwave power transmission during CBS News program, microwave powered model helicopter that received all the power needed for flight from a microwave beam. 75. Bill Brown was technical director of JPL Raytheon program that beamed 30 kilowatts of power over a distance of 1 mile at 9.6. That's the thing, 9.6 efficiency. What does that mean? Is it like my intuitive understanding is that 9.6 efficiency means that you only the only usable energy you have, like you only yield 10% of the total power or energy that was available. The beam does not sprout due to diffraction, or is saying that only 9.6% was lost. That's what I'm curious about. 68. I would like to read this. Very cool. This is what we're doing. Alright, evaluation of microwave high power reception conversion conversion array for wireless power transmission. Initial performance test of a 24 area of represented. The array is used as a receiving portion of a wireless microwave power transmission engineering verification test system. The transmitting antenna was located at a range of 1.54 kilometers. Output DC voltage and power, input RF power, efficiency, and operating temperatures were obtained for a variety of DC load and RF incident power levels at 2,388 megahertz. Incident peak is up to 170. The highest derived collection conversion efficiency of array was greater than 80%. Okay, interesting. So this is lining up with the idea that most of the energy was actually transferred efficiently. And 1.54 kilometers. How thick is Earth's atmosphere in kilometers? Atmosphere has a mass of 3/4 within. Thermosphere, known as the upper atmosphere, while extremely thin, the gas of the thermosphere became increasingly denser as one descends. Yeah, that makes sense. Okay, so 600 kilometers. So I wonder how this would change as, because that's 1.54, and if they have a loss of like 10% or 20% in this case, in their best case, a loss of 20%. I wonder how that would scale when we go from a range of 1.54 kilometers to 600 kilometers. Yep, and here's 600 kilometers. Though, in all honesty, we only have to worry about the first, or the biggest impact would be like the first 50 kilometers up to the stratosphere. That would be like that's where like a bulk of the particles that can interact with that lies. And even then it's a gradient, so like most of the water lie here within the troposphere, the tropopause. This is super interesting though. Mesosphere. Okay, yeah. So there is. Huh. There's some bite to this. Oh, there's instructions how to fill out a technical report. Super interesting stuff. Rectenna elements are combined into a subarray of 270 sub-elements arranged in an equilateral triangle grid. Okay. So our Dyson sphere, what I'm seeing here is that there is a tangible way for our Dyson sphere, our fictional Dyson sphere, to be able to transmit energy to whatever planet based off of this NASA paper, which honestly you probably didn't have to go into so much detail for the sake of level or world building, but this is interesting at the very least. This is interesting. And it has some implications here. Okay. So now it's a matter of the flavor of our Dyson sphere. There's like two different, so there's like three things. There's the designs that seem to be oriented around having like nodes or strips around it, where it still allows a lot of energy to leak out, but it has like this grid of different nodes that can receive stuff here, and you would have a mesh. There's the one I'm describing where it's like a shell that encapsulates it. And it could take many different forms. I'm thinking of more like an eyeball. So that we can still allow light to leak out to other places. Yep, so we got the escape, allowed it to escape there. And then there's like the Dyson Swarm, which I'm assuming is you have a bunch of loose satellites that orbit it independently. Each of them beaming their own energy to whatever planet. You know, I kind of like the idea of a Dyson Swarm. I think visually that'd be much cooler. Dyson Swarm. Yeah. Look at that beautiful array. Yeah, completely artificial. A completely artificial ring around a planet. That'd be pretty cool. Oh look, Dyson ring. Okay, that's like different types. Ring, swarm, a bubble, and then a shell. That's the different things you're describing. Those are different ideas that are at our disposal. What may it look like to be like? I think a Dyson sphere might be more feasible. So let's say like our Dyson's form thing is going to look like this. So it has to be really big to make this worth it. Like how big would this have to be to make it worth it? I mean, I'd have to concoct some kind of fictional number to understand, to create a cost, and then use that cost to derive the break-even point for yield consumption. Let's say within like the first year, maybe. Yeah, one side that's like blazingly hot, and the other side that's just. Let's look at this again. So let's operate with the idea that we're doing the shell approach. Let's say within this shell, you can see like the fire of the sun below here. This is important. We need to define this stuff. Because then I can start making tiles and assets, and we can start using the level editor. But right now, I don't know what I want to make with the level editor yet. We can make simple tiles and have the object move around, but I need to have a vision. I need to have a vision for what this is going to be. For where this guy's going to be. Without a vision, the people are lost. Without a vision, the people perish. It's a good quote from Proverbs. Maybe we don't even show the fire. We just show the aftermath, because the Dyson's like, okay, if we look at the closer look at the surface, it's not gonna be right on the surface. It should be, I imagine for peak efficiency, it should be as close as possible, but it's not gonna be perfectly on it. And we're gonna have some kind of structure that's just hugging the surface a little bit. Hugging the surface just a little bit. You probably have two sides. One that's like meant to receive all the energy, and then another side that's meant for maintenance and all this stuff to keep things running. Probably like a launch pad or something. Because why not? Why not have this Dyson, these things be inhabited by people who have to maintain it? Like, why stop there? Why not make a city? Have generations of people who live in the Dyson sphere and service it. Yes, clearly. This is what we do. Imagine seeing the solar flares coming from over here. Humongous solar flares. He's got a little city that's just chilling here. Chilling as can be. orbiting, so it's gonna be a zero gravity kind of deal. So you can have like loose structures. Because once the building material is matching the velocity of the area relative to it, why not have it just be have buildings suspended? Why not? And there's adjacencies, co-orbiting platelets. Maybe not all plates are inhabited. Maybe only a few of them are, or there's like a main one. That has people that can go out to other parts of other sectors to service them. Or maybe there can be like stratification, so we can have our layers. So you have like some that are lower and more overlapped with this. This is turning more into a Dyson strip. But we can turn it into a sphere or swarm. Yeah, huge field of these guys. But then like have like yeah, we can have like one that's orbiting over this. Oh, we can have like some here. Ooh, how do we want to do this? 'Cause I'm thinking of like having 3 layers. Just for visual coolness. Like one down here, one above that captures the gaps. And then one for like this little city that would come about in the middle. So why not? It gets to overlook stuff. It gets to see the panels doing their work, beaming stuff to the planet. Hey. I'm liking this idea though more and more. This might be good enough just to depict what's in my mind. And of course we're gonna have gravity, because why not? Why not? And then we have this technology here. Windows. Little portholes to give you a look to the outside in some form or fashion. Then we can see like do the scale right. Humongous adjacent receivers that are super illuminated. I kind of feel like I need to go in Blender to like, if we're gonna do this geometry thing, I want to kind of get the perspective in an interesting spot. Accurate and interesting. Yeah. So what would be the technology? Like, what would be the technology that enables this. How would a Dyson sphere convert energy or convert solar rays or capture energy? Let's say that. No, I'm not. Now I'm not worried about transmitting. I'm worried about. I'm interested in learning about how it would capture the enemy. Like, is this using a regular solar panel, like, to capture sunlight? Okay, but I want to know the mechanism here. Concept photovoltaic Dyson sphere, a megastructure designed to capture. Yeah. Photovoltaic conversion. The semiconductor sphere must be coated with a black material to regulate temperature. How? Ensuring it remains low enough for photovoltaic generation. The environment impact. Parsonage. 4% of Earth's sun power. Wow. So generate 4% of the sun's power, yielding 5.6 yodawatts, I'm assuming, of electricity, while increasing temperature on Earth by less than 3K. That sounds like a great deal. It sounds like a great deal. Okay. I'm just going to assume that most mechanisms on these things are going to be meant to cool. Mechanisms for cooling Dyson spheres. Not interested. No, I'm not. I don't care about the ecosystem. We don't care about the ecosystem. We're just caring about how, in this fictional world, what would be the needs for this Dyson sphere architecture, so we can design a level and then work with it. Yeah, you got the hand cam right now. You got the hand. What's up, DMK? It's good to see you, man. So you can see my fingies when we do stuff like this. But right now, we're just thinking about not terraforming. We're digging through government NASA papers and just figuring out, how do these dang Dyson spheres work? Also, DMK, I'm not sure if you've seen. I'm not sure if you've heard. But I've been doing something a little goofy. A little goofy. Eye contacts. No. I've done a little thing, a little ingy poo, just for the funsies. So we're not sure. I'm not sure how Messy Mansion is gonna be coming about. Maybe we would take a pause just so I can finish writing this engine, and then we could start working on converting Messy Mansion to work on this bad boy. But yeah, I'm planning to make a proper update for everyone. Yeah, I see. Like it's exactly everything I've wanted. It's everything I've wanted. It's in C++. No stupid Rust. I did in 3 weeks. I did what took me like a year or two in Rust. And if you look at the hand cam, you can see like this whole level editor is exactly what I want. I can navigate and move things around using just the keyboard. It's so easy to define. Oh, dang. Dang. I think it's my first seg fault I've had. Like a real seg fault that wasn't intended or known. But yeah, buddy. Optimal performance. Everything a gamer needs. Oh, maybe we need this one. Doop. Doop. Bam. Level. Messy Mansion is the essence of all the products made by Cozy Kevin. Messy Mansion is inside all of us. It's the friends we made along the way. Messy Mansion is the friends we made along the way. It's spirit. It's an essence. It's like this candle right here. It's an aroma. Ooh, yeah. Yeah, I don't know. I don't feel like I have the vision in Messy Mansion. It's a cool mechanic. The cleaning thing, it was a fun thing. Sonic debug mode so far. The Sonic... Wait, what are you talking about? I've heard, like, seen the Sonic test stuff, like the audio test stuff, but I haven't seen the debug. Either way. We're making an engine that fits like a glove. Okay, and here's the thing, right? Here's the propaganda, too. This is the Unity hate propaganda. But, like, if you compare the performance of this to, like, Unity... Like, I remade this game in Unity with way less features, and it still has, like, a bigger memory and processing overhead. It still takes way more, like 2 times or 4 times more to do less. And I imagine the more you scale in complexity, the bigger it gets, which is not that crazy because modern systems are beefy, but there's also a part of like making like treating software like art. Like, why not try to make lean and efficient software? Why not try to do that? Why not try to do that? I mean, I know why not. But you have the power to. You have the freedom, and you have no life. Hey, I have a life. But you have the will. Why not just try to make something lean? Like, sure, Joe Schmo's not going to notice, but I notice it, and that's who I really care. That's who I'm making the game for. It's not for people. It's for me. It's the extra fun. Exactly. It's fun running this on the unbounded mode because you get like 6,000 something FPS. Though it's like fast enough for like the delta time doesn't work properly, so game logic actually breaks. But like if where's the render module? And we're not doing the Raylib stuff. This is all mostly handwritten. Like we're using GLFW and using like M audio for stuff, or mini audio. And then MathFoo for the vectorized math. But that's it. That's it. I think that's pretty much it. Where is this? Where is this John at? How you doing, DMK? It's been a fat minute since I've taken a little break. A little napsy doodle. Here we go. Unbounded GLFL swap interval 0. Do I have the thing that indicates FPS? I don't think I do. I know it's gonna break. Yeah, like jumping is like not gonna. I don't know what it is. Delta time is funky. It's odd. But if we output that old performance. That ye old performance. Oh no. I think I have it commented out. Yeah, here we go. See out frame rate. How's the break? It was good. I needed some time to get away from Newgrounds and just public online exposure. Yeah, look at this joint. 4,000 frames per second, 5,000 frames per second. That's bad performance. 1,000 frames per second, terrible. No, it was good to take a break and just reevaluate things. I think there's important qualities. So a lot of my time has been kind of wondering what is good quality for leaders, right? It's not a question I've been consciously trying to solve, but it's just something that's been in the back of my mind. And throughout my break, I've been kind of exposed to different people in leadership in different places and positions, both like my day job, even in not only my day job, but also in the world, online, YouTube, companies that I actually like specifically follow, and then individuals too, and seeing like, and then also looking in history as well as like, well, who are previously good leaders, like even in the tech space, right? And what I've started to come to realize is that the most important quality for a leader, and in my opinion, right, and it's not to say that if you have this one thing, you have it made, that nothing else matters, but the big important thing I saw is that good leaders that make impacts and big changes are ones with vision. Having a clear vision for what's to happen and what's to go in the future, right? And I started realizing that the vision for Cozy Cabin, there wasn't quite a solidified vision for what I'm trying to do here, aside from I'm just working on stuff that's cool. And that's not necessarily wrong per se, but I think at this point I want to have more clarity in terms of what is the overall aim here, what's the overarching goal I wish to achieve with this game studio and what we want to do. And there's a couple different components onto it. But yeah, that's something that's very important that I started coming to realize, and something that I've been refining more and more. I have an idea for what I want Cozy Cabin to be and what we're going to do. But part of it's like balancing in some sense. I think there's a clear idea in my mind for the experience I want players to have. And then there's also a balance in like personal ideology. Like even like this whole game engine thing. I like that I want to have that independence, right? To be separate from this general ecosystem that everyone's kind of opted into in some form or fashion. And have a product or make things that are just fundamentally different, not only in terms of what's presented to the user, but even under the hood. Because I think what happens under the hood affects the general, even if most people don't quite notice it immediately. So, but I want to make a proper video. I want to do a proper write-up of this vision, quote unquote, and make a video and see if you guys can see what I'm seeing. If you can smell what the Rock is cooking. In the meantime, we're just doing some R&D here, which is essentially what we're doing. This is just R&Ding, making tools so we can do the things we want to. Because, by golly, I really want to ditch Unity. Like, here's the thing, right? So here's one example of why I kind of started doing this. Unity's WebGL builds break on like Linux machines or just some Windows machines on web. It's weird, right? Because it's a web browser and you'd expect it to behave the same way because it's just JavaScript at the end of the day. But for whatever reason, Messy Mansion breaks on Linux machines. And it's broken in a way that I have no control over. That's the thing that bothers me. It's that when I did research into why this controller stuff doesn't work the way you intended to, and why does it feel fine on my machine and not on this machine. By the way, I switched to Linux, by the way. Just letting you know I switched to Linux. Okay, now it works somewhat fine now. And before it didn't. It was super glitched out and the mouse was not working fine. I think I did like last stream. You can probably see it there. Fun. Awesome. Either way though. But yeah, that was a whole thing. And the consensus was online was like, hey, you can either just try using a different version of Unity and hope that issue got fixed. But the larger response was, yeah, Unity doesn't care about the WebGL export, so you're probably not going to see any fixes for these weird mouse inputs. You're not doing anything wrong. You're using Unity's new input system. Unity promised you this set of features that you can work with, and you agreed to those terms, and it's just that they're not honoring those terms on this export for platform, which sucks. So, by going off-road, it's more work because I have to support what I'm doing. But in these scenarios where it doesn't behave the exact like the way it's supposed to on platforms, I'd at least have the power to actually fix it. Okay. That's just one thing. There's a bunch of other things. The Cozy Vision, a look into the leadership of Cozy Cabin Games, is just so well optimized that web browsers can't keep up with the optimization, so it breaks. It's not the compiler's fault. It's the machine's fault. It's the people's fault. Why are you getting mad at me for compiling bad? It's not bad code. It's just that what you wanted it to do was wrong. You wanted to have a functional game that works consistently, and that's just a wrong request. That's just invalid. There was a compile error in your mind when you concocted that idea. That was the real problem here. You dare to dream. We don't do that here. My goodness, it's been a while since I've been on here. You guys remember Messy Mansion? I remember Messy Mansion. That was a trip. Oh, there's like double sounds of like nature. That's not great. But yeah, there's a whole thing. We're gonna have the video. You're gonna walk with me. We're gonna walk and talk. Hopefully you'll get the idea of what we're trying to do. What's the overall vibe you wish to achieve? But for right now, building blocks and then maybe some nerd stuff. I learned. It's amazing. Sometimes you think, oh, I'm actually getting so good. I'm getting good at programming. I'm learning stuff that I didn't know before, and I was scared to learn. And then you just learn there's another level to this game, and you go, oh my goodness, I'm a fraud. I don't know nothing. I had a moment like that kind of today. With like learning about intrinsics and AVX. Which feels like magic. Like I've known of it, but I really didn't know much about like how to even approach dealing with it. I'm not sure if we're gonna do it today. I'm probably gonna spend some time in private just like messing around and with GCC and or Clang or something and trying to do it. But it's like another level of like it, you know, you have control over stuff and you can optimize for a specific platform and get crazy results. Oh man, so much to do, so much to learn. Oh man, but yeah, that's just the general state of things and kind of what we're doing right now. I feel torn though, because I do like Messy Mansion was nice, and I started implementing some new stuff in it. Yeah, I installed this malware that is called Unity Hub onto my Freedom machine. I don't know anything beyond the bare minimum C#, which is why I honor the ancient code of fake it till you make it. Hey, I mean, it works. It takes you places, man. I mean, that's how I got my first... Like, that's how I got this job, honestly, dude. I feel like I was super underqualified to get my current job. I don't know what kind of role I managed to pull to just, like, to get it. I don't know how. But, yeah. Ever since then, I'm just playing... I feel like I'm playing catch-up. I'm just trying to learn as much as I can, dude. I just want to get good, man. I just want to get good. Heck, even with C#, there's like levels to the game. Have you played with the job system at all? The job system is a whole different... There's a whole level there, man. It's pretty cool. It's kind of what kickstarted this whole AVX intrinsic stuff that I started learning about today from a pretty cool dude. Oh man. Oh yeah, I was gonna click on Messy Mansion. That was gonna do. Oh, it's already opening. Wait, what? It could not open. Wait, what? Why can't you open? Is it already open somewhere else? Please tell me that's what's happening. Wait, what? Why did it fail to open? What? The frick is a job system? Okay, we're gonna learn something today. It's pretty cool. Access to file is denied. What are you talking about? It's denied. I own this file. I am the owner here. What are you talking about? Okay. Okay. We're gonna talk about the job system today, because I think it's cool to know about it. I think it's a helpful tool to have in your toolkit. I don't really know too much about what you do, DMK. I know I've spotted you in the game, the GDK Discord. I was like, oh, cool, you're GDK person. Let's go. Sweet. But I'm not sure if you're speccing into pro, like what your build's looking like. Are you speccing the coding or art or what have you? Either way, though, if you learn like what the job system is, it's cool. Opens doors. I think I mentioned it for, there's that stream we did a while back where that guy had some issues with his RTS and some big performance issues with that. Okay. I'm probably just gonna make a new project and just hope that works. The heart, no, we're gonna do home. I do a bit of everything. Hey, okay, a fellow polyglot, a renaissance man, if you will. A renaissance man. A polymath. Yeah, that's the correct term. A polymath. Not a polyglot. That's like multiple languages, I think. Projects. No, not projects. We want to organize this a little bit. Examples. And yeah, we're going to use this. Select folder, create project. We're going to be learning today. And let's wait for Unity to take forever to load. So, okay. C# land. So in general, right? I'm pretty sure you've known that there's like levels to coding languages, where there's like languages that are considered high level and then other languages that are considered low level. And usually when you talk about high level, the idea is that they're more abstract and maybe closer to human language, but it comes at a trade-off of like speed and performance and whatnot. And then if you're dealing with lower level languages, you have to manage things and deal at a more lower level, but the trade-off is speed, right? And C# is a somewhat high level language. Do you know what separates what kind of creates a big performance difference between C# code and C++ code? Out of curiosity. And if you don't, that's cool. In all honesty, man, in thinking about this right now, I'm like, I haven't really thought about this too much. I haven't thought about this stuff too much. Or at least in a very long time. And I'm trying to remember why do we do this again? Why do we do this stuff? No. Okay. So, one element of this is that C# has something called a garbage collector. There's a thing called a garbage collector that exists in C#. So let me pull up Miro. It'll be a fun little educational thing. It'll be good for me to refresh my knowledge. And there's probably more. to this than I even know, because I haven't even thought about this, to be honest. Miro. That's, yes, login. Yes, dear, you can have all my social, all my emails. Yes, honey. Have all my personal information. Thank you. Okay, so let's say you have your computer. And you have RAM. Let's say you have RAM. This is your dedicated RAM. So in a language like C++, you have to actually manage what goes in and out of your RAM. Typically, or specifically, usually you're managing, most of this considerations happens in something called the heap. So let's say, you know, we have a, in fact, let's get, this is too much information. That's too much. Let's dial it back. Let's cool it for the Jets a little bit, okay? Let's say we have struct, I don't know, player. It should be familiar. That has a, I don't know. I usually use Unity structures, Unity things. Vector 3 for position, right? Maybe they have another vector 3 for I don't know, velocity. And then maybe they have a name. So somewhere in your C# code, you're gonna have a function that does something. For example, let's just do main. In fact, let's keep it simple. So in C#, you do, hey, I want a player, so I'm gonna make player, I don't know, player, Bob, let's say, equals new player. And then maybe you pass in some values for these things, like position is something, and then etc., etc. You set your values here. Well, you say, okay, we're gonna put this on, we're gonna allocate this somewhere. We have Bob, he now lives somewhere in our RAM. But then that's about it, right? So if nothing references Bob, C# does this cool thing which is called garbage collection, which is that they eventually check to see, hey, is anyone using Bob? If not, we're gonna get rid of him. Whereas in C++, that's not the case. If you allocate something to the heap, you have to actually free it at some point. So you say, hey, we're gonna allocate this player onto the heap, and then somewhere later on in our application, we need to call free on Bob. So here, we're manually managing our memory. We say, hey, in C++ land, I tell you when Bob is gonna live, and then I have to decide when Bob is gonna die. And sure, modern C++ has some abstractions like unique pointers and whatnot to make this a bit easier, but this is, in general, what goes on in a manually managed language. C# makes it very easy. It just says, hey, is anyone using Bob? If not, then we can kill him. We can send him to the Gulag, all right? But there's a cost to this. And that cost is that garbage collection is something that is a background process that's always running in the back of your program. So garbage collector is always running and checking to see where everything is going on and managing how many things are referencing Bob and whether or not we need to kill Bob, right? And then the layout in memory is kind of outside of your control. The garbage collector may put, let's say like this is the actual layout here in memory. You know, one frame Bob might be allocated here, and then the garbage collector runs and moves things around, and then now Bob might be allocated over here instead and whatnot. So the garbage collector adds its performance overhead. It's always running and it's always managing this count. And likewise, you don't have control over memory. So it makes things a bit slower. So what if you have to do something that's kind of performance intensive that needs to be very quick and fast? You want to have C++ level performance while still working within C# land. Well, this is where jobs come into play. Jobs are this really, really cool thing that Unity created. I'm gonna have to add a specific package for this that enables you to have your memory in a predictable place and having your code actually compiled. That's another thing too with C#. C# isn't a compiler. It's eventually, depending on what kind of backend you're using. C# is a JIT program, so there's a bit more that goes onto it, but it isn't necessarily compiled directly into an actual executable, or like it's not compiled down to, I don't know, I have to actually look into this. I really don't know too much about the JIT compiler and the intermediate language stuff, but there's like steps to how C# runs, and you can either use mono or have it compiled down to C++ code. But yeah, there's other overhead here. So what we're going to do is we're going to go to Window, we're going to go to Package Manager, and then let's see if Unity has this available here. Do we have Burst available? Oh, in project. No, I want the Unity registry. Burst. Here we go. Install Burst. Has an execution built in, but in C#, yeah, you're left with the moral quandary of killing Bob. Exactly. C#, you have the knife, or in C++, you have the knife. In C#, the village has this guy who's going to be taking care of it. Okay, you have a village executioner, so the guilt isn't on your hands. But because of that, the guilt is really on everyone's hands. Anyways, you have this. So there's a package called Burst, and I think there's another thing called Collections, if I'm not mistaken. Yep, we have to install that too. And what's going to happen here is that we're going to do a little example here. And this is particularly useful in situations like you have a ton of elements that need to be operated on. And depending on what you're doing, you can even treat your CPU kind of like a GPU, where you can execute things in parallel. So we're gonna go through examples of this. Okay, we're gonna make a new script. I don't know, called demo. New script. Demo. Yep. Create add. Then open it up in not this. I want to open up in a proper IDE. I want to use a real man's IDE. Preferences. 1 second. I've been pampered by my tools, and now I can't operate without them. Really? You don't auto detect writer? Man, Unity on Linux sucks, dude. I'm not gonna lie. Maybe that might be the other reason why I don't use Unity, is just because I don't want to deal with this. Like, why did you become small? Okay, 1 second. Project resources, preferences, external tools, and then open by extension. Where's my code editor? I'm trying to choose my external script editor. Browse. Okay, here we go. Home. We're gonna go to programs, and then I have writer here. JetBrains writer. Bear with me for a second. Don't garbage collect your memory yet. Hold on. Trying to drop some game on you. Where's bin writer? Here we go. Sweet. And then this should just regenerate project files, and we should be good to go. And life should be happy. Everyone should be happy. And then writer should just work. Trust and open. I trust it. And so I bought some extra RAM, so now we can actually have 2 beefy IDEs open. Sweet. Okay. So let's make a example here to iterate the point. So let's say we have like, I don't know. Let's say we have a struct called enemy. And let's say they have like, I don't know, float HP equals, I don't know, 10, 100. Okay, we can't initialize it. I forgot about that. Okay, they have HP. Maybe they have some other thing like, I don't know. Let's use a float 2. No, we're gonna keep it simple. They just have HP, right? Keep it simple. And let's say we have like 1,000 enemies. In fact, we should probably make this private so it doesn't get serialized to Unity's inspector. You have an array of them. Enemies. And let's go crazy. Let's go nuts, guys. Let's go for like 1,000, 10,000 even. Let's go even crazier. Let's go like 10 million. Can we not do that here? I thought we could do this in C#. Oh, I think we can. I just have to do this new operator. Did I really have to specify it? Oh my goodness. Okay. Anyways, you have 10,000, 10 million enemies. Cool. Or maybe let's make, maybe not as big, because I want this to actually run at a decent iteration. And let's say we want to, like, I don't know, do some kind of update to them. We want to change their health. Let's like decrement it by a certain amount. So there's like 2 ways we can do it. We can do Unity's basic way of doing it, where you can have enemies, and then we can do for each of them. Or actually, I want to do for, and then you can do enemies dot HP, and then minus equals, I don't know, 1. We apply the status effect only to like to all of them, right? Blanket. And this might be a normal way of doing it. So this classic C# way. And this might be practical in cases like, let's say you have a bunch of bullets that are doing stuff, or I don't know. If a game can't handle 10 million, 10 billion, trillion, 100,000 polygon enemy objects on screen at once, it's not optimized enough. It's the game's fault. It's a programmer's fault for not making that happen. That's a skill issue, really. Really, that's just a skill issue. And then we have this job thing. So we're gonna do a cool thing. I'm putting on some game today, okay? You're gonna learn about profiling. Profiler. Begin sampling. So we're gonna sample the performance of this version of Unity's classic way of doing stuff. So vanilla, or let's just take a classic. And then we do profile end sample. And then here we're gonna have our job way of doing it. So let's actually just run this. In fact, let's move this into update. We're gonna do if, let's make it like when you press space, it runs this. Input.get key down, key code, space. And we're gonna do it inverted because we wanna be clean. So cool. So in update, when we press space, we're gonna do this guy. That sounds weird out of context. So we're gonna do this version of running it, and we're gonna have the Unity profiler, and it's gonna be a rousing round of fun stuff. And we're gonna see how well this handles it. So we're going to go to where's window, where's analysis, profiler. Cool, and then we're going to run it once we enter the game. And then we're going to press play. And then we're going to press space. And then you're going to see something, I'm hoping. Okay, so I'm assuming we see this big spike here. I'm assuming this is the classic thing. Maybe we just need to make it bigger. That wasn't that big of a spike, in all honesty. In all honesty, that wasn't a big enough spike for me. Hierarchy. Classic. One second. Yeah, I spelled classic correctly. Unless this didn't recompile. Hey! What's up, Kiran? Bit late, but hi. Good to see you. Yeah, I'm showing off some... I'm showing off the job system to our boy DMK. So you can see a little bit about optimizations. Or just cool tools that Unity gives you. If you want to do like C++ level like performance. One second. Okay. Alright, let's have a bigger spike. Let's make this even more bigger. Let's do like extra 0. That shouldn't be that bad, right? If the computer can't handle it, it didn't deserve to be a computer in the first place. Am I right? Alright, let's try it again. Hopefully we see a big spike when I press space. And let me clear this. And then we're going to press boop. Oh, wait, one second. Let me also change one thing. This should be key down, I believe. Oh, no, it is key down. Alright, let's see if this popped up at all. I'm not going crazy. I'm not going crazy, guys. I know for a fact this should be here. I know I pressed the button. I know I made it do stuff. Why am I being lied to? Alright, maybe you just gotta up it, guys. Maybe you just gotta up it. Maybe I'm just not shooting for the moon enough. Maybe I'm not making this computer work. 100 million. Why not? Shouldn't be that crazy of an operation. And in fact, we're going to go an extra step here. We're going to make sure that this it's a standalone process. I don't care. I don't care. I know what I'm about, son. I know what I'm about. I want the truth. Thank you. Clear on play. That's exactly what I want. And then let's also make sure that this is actually debugging. So I'm going to print out something. Hey, to make sure that this is doing the thing. And this is why people have prepared demos. Okay. All right, beautiful. So clearly did the thing. And I think it just was really fast. Here we go. Finally, a blip. Classic. Not console. What I'm looking for here. I want to see the hierarchy, please. Call stacks, nope. One second, I'm trying to find the hierarchy. General console analysis profiler. Key profiler and profiler. One second. Where is the thing? Oh, timeline. I'm dumb. All right, here we go. Hierarchy. And classic. Okay, now we're good. Here we go. So we have our classic. And we see that it takes like 139 milliseconds to execute, which is kind of crazy for like a single frame. Imagine if you're doing this, like, imagine if you have RTS and you're doing a bunch of updates on this continuously. That's kind of insane, right? So there's ways to make this better. So we're going to show you two alternatives. We're going to use a job system with plus burst. But then we're going to also do a job but parallelized, where we just say, hey, your CPU is actually a GPU. We're just going to treat it like a GPU. So for this, if you want to use a job to execute the structure, you have to constrict yourself into certain limitations. So if you're going to go to kind of a C++ level of like speed, you're going to have a little bit of a restriction in terms of how you do stuff. So in the case of jobs, you have to make a struct that defines the operation you want to do. In this case, it's like an enemy status update, let's say. And you have to use something called an interface, and it has to, this enemy status update has to inherit from this job interface. And you press Alt Enter, and it's going to show you stuff here. And just to make you guys not squint at the screen, I'm just going to increase the size of the code for you. We're just going to do that because, what can I say? I'm just that great of a guy. I'm such a good dude, man. Making legible code for you guys, that's crazy. So you make a new struct, give it a name for whatever we're going to do, and it's going to inherit from this iJob interface. And this iJob interface needs you to have this method, public void execute, and then we're going to do something here. We also have to specify this information because jobs can't just use normal arrays. Because normal arrays are in this world, C# world of managed memory. And we're diving into a world of kind of unmanaged memory where you actually have to dictate if something's going to live or not. We're putting the knife back in our hands, and we're gonna decide if we're gonna kill Bob. So the native or C++ way of thinking about it, it's not actually C++, but this job way of thinking about it is something called a native container. And you have native arrays, and it's basically like a regular array, just native. And you specify what kind of type you're working with. In this case, we're dealing with enemy structs, and a bunch of enemies. So enemies, and then we also, it's helpful to specify what you're going to do here. So in this case, hey, this is a write-only operation. You don't have to even specify that. So this is the input we're given, and we're just going to transform it. Funny, I was squinting. Yeah, okay. What can I say? I know my people. I know the people. I'm kind of an empath. I care so deeply about people. No, I just realized, I looked on the screen, I was like, oh, that looks really small. Maybe I should probably size it up. Anyways, and then here, we're going to yoink the same operation we did here. This float, this little thing of just, hey, we're going to modify this. Yeah, we're going to change that here. And we're still going to do our little iteration. So we're going to do enemies and do a for loop on this John, on this joint. Oh, you're not going to do this to me, are you? You're not going to do this to me. Fine, I'll type it out like a jabroni. Equals 0, I less than enemies.length, and then I plus plus, like a plebeian. And then, of course, it has to be public. We have our native array of enemy. And we have enemies. Why are you mad at me? Access returns temporary value. No. I have to set this value. What do you mean return temporary value? What are you talking about? Do I have to actually like use a separate variable here? Okay, here we go. Okay. So we get our enemies from this index. We apply it here. And that's the job right here. We finish it. GG's. But now we have to actually use the job. We define what this job is, but we actually have to execute it. So first we're going to create our job. Enemy status update job. And you're going to make a new instance of this. And then we're going to we also have to provide this. We have to allocate this here. So we're going to make a native array of type enemy. It's fine. We're going to call it data. Make a new native array. And then we're going to yoink this here and put it in here. In here, my bad. So, enemies. And that should be fine. And then here's the managed memory type. This is the managed memory area. This is where we leave the garbage collector and say, okay, give me the knife. We're gonna kill Bob at some point. And you have a bunch of different options here. So this is how you allocate your memory. And in general, you only have like 3 real options. You have persistent, which says, hey, I'm gonna allocate this memory here. We're gonna allocate Bob in here, and then I'm gonna decide when we kill Bob. Okay? I am going to kill Bob. And then if you wanna be a little bit, if you're not gonna have this data for a long time, if you're using it only for like 1 frame, you can instead use something called temp memory or a temp job. And then this is, you don't have to kill Bob. It's just gonna, after 1 frame, it's gonna free it. It's not gonna, you don't have to worry about it. But just so you can see how it looks like if you're gonna have this, let's say you're gonna have this data around for a while. To kill it, you just do data.dispose. And that's how you free it. So we have our data, we have our job, and we freed it, but we have to actually execute our job. So we go to job, we do schedule, and then that's gonna schedule the job to be executed. And then if you want it to happen right now, you just do complete. And it's gonna force the job to happen. It's gonna block your main thread until the job is done. Now let's compare this. We are gonna compare this. We have profiling here for classic. Now we're gonna have the profiler for the job. And we're gonna call this job. And we should probably have this be burst compiled if you want it to be super duper fast. I forgot what's the thing for that. Let's just see how it looks without that. So we're gonna go back into Unity. We're gonna stop play mode. It's gonna recompile domain. See, it has allocators. It does. Well, C# with C# has unsafe, and you can do weird stuff with that. But there's also Unity's burst compile system, which allows you to do really cool stuff. Like in actual application, I've used this, and I'm currently using it for stuff like 3D mesh generation and processing, where that's a lot of data that you need to have be processed in an organized fashion. All right, we have this here. We press space. Oh my goodness, I did something wrong. Why are you mad at me? Oh, because I didn't allocate it, my bad. I didn't assign it. My bad. You see this variable here? I didn't assign it. You kind of have to do that. It's kind of important. You don't want to have no invalid data. 1 second. And then, why are you mad at me? Oh, it's a private field. Ha, my bad. Public. Cool. And now it should be fine. That was a little test run. It's okay. We make mistakes. It happens. This time for real now. This time's for real. We press play. It runs. We press space. Bam, done. Let's take a look at what happened. So, okay, we have our spike here. And then we have our, oh, I'm stupid, I didn't name the thing. So we have two classics. This one's the burst. So in the C# normal way of doing things, in fact, let me shrink it down so you guys can see the actual performance gains here. The normal C# way of doing things is 132.9 milliseconds. To do the same operation, how long did this take? It's showing 0. That's no way. There's no way it's that fast to just do that. All right, guys, there's your performance boost. It takes 0 instructions to do this operation. No shot. No shot. No shot. All right, let's have a validation thing. Let's have a validation thing. We're gonna do a little, or let's just bump up the, let's add an extra 0 and see what happens. Maybe it's just going so fast it's not being picked up in milliseconds. Oh wait, 1 second. No, I'm dumb. I did name it correctly. I did name it correctly. Yeah, here we go. Here's job. Never mind, guys. Just kidding. Just kidding. So we have, okay, I should have named it a better thing because there's other tasks called job. Classic. And then job. All right, 1 second, guys. We're going to make this easier to organize. It was ended in the script. No, yeah, you're right. It wasn't ended. That's why it's calling doubled. My goodness, DMK. Good catch, man. What a freaking good catch. Yeah, I just saw a job and it said like 600 milliseconds. I was like, that's not right. That's no way. Okay, we're going to make this easier to find and compare. We're going to prepend it with test.classic and then test.job. Okay. Now this is a real example. Now we're going to actually, this is going to be for realsies. Such a good catch, dude. Such a good catch. All right, now we're going to run it. She's completing the domain. Complete the domain. All right, press space. Okay, I'm assuming it ran. Oh my goodness. Unity crashed. Yeah, that's the thing that happens, guys. When you start using jobs and burst compilers, that's a thing that very well may happen, which is Unity crashing. And I think I slammed I did a bit too much, I guess. All right, let's open up. Why is it called My Project? It's currently open in another. Unity! Close the profiler. Here we go. Okay, maybe did. Let's chill a little bit. We'll bring down a 0. We'll bring down a 0. It's okay. And now you know how it's like for me to work at my job, because this happens all the time. Unity crashes all the time because we're doing weird jank stuff. The job was so fast, Unity couldn't take it. We operate at speed of crash. Okay, let's try it for real. And then let me also add back that little print line because I like having confirmation that I did something. Oh, it's there. Okay. And then let's go to Windows, Analysis, Standalone Process. I know what I'm about, Unity. I'm a big boy. Okay. And now we have this. We can type in test, and we're going to have a nice comparison here. Okay, we're going to run it. App domain. We press space once. I'm scared that I may have crashed something. Nope, we're good, but I didn't see the thing. Though I did see a huge spike here, but I don't think that's test. One second, let's let her run. Maybe it's running right now. Maybe it's taking a minute, because I haven't seen the print yet. But editor isn't blocked. How's memory? Memory's fine here. I'm pretty sure the key is space. Yeah. Unless, oh, the component's not on there. I didn't save the scene. So I'm pressing. Okay, this time is for real, guys. This time I mean it. I mean it. This is for realsies. Okay. Now we're gonna press space. There we go. Finally. And then now we're gonna see this spike here. And cool, now we have a comparison. Let me bring it smaller. Bring it down right here. And you can see our classic way of doing it takes about, let's see, let's get some actual concrete numbers here. So the classic way took about, what? What is going on here? Oh, because I'm using persistent. That's probably why. Yeah, allocate. So the persistent allocator takes more time. Just a FYI. So usually you want to save this for when it's humongous, a large amount of allocations where it becomes fine. Let me compare this. We're learning today, actually. That's interesting, though. So job 602 milliseconds. That's likely due to the allocator running, and then the classic takes 132 milliseconds. Okay. So let's do little optimizations, and let's add the burst compile flag, because I think that's the bigger thing. 1 second, I forgot the flag for it. How to flag for burst compiler Unity. Oh, you just do burst compile. So you mark this with the burst compile attribute. No, burst compile. Sweet. And now let's compare this. Now it's kind of cool to know, because it's not like, hey, this is always going to make things better. If you do things dumb or wrong, it actually can be worse. But now we're going to try this for real. Or with the burst compile and using a temp allocator. We have our hey. And let's go back to here. And then now we go to spike. And then cool. So let's take inventory. So Dob is 373 milliseconds. Okay. And then 134 milliseconds for classic. Dude, what? This is so weird. Does it have to be like even crazier operations going on there for the break even to happen? Okay, 1 second. This is interesting. I'm using the temp job allocator. I'm not using temp though. Dude, this is weird. I haven't... Oh, and I'm doing data dispose. We don't need to do that. I wonder if that changes anything. We're both learning today, guys. Okay, let's see this. That's goofy. All right, space. There we go. Pause. Yoink. Where'd it go? Was that too slow? I think it was too slow. Okay. Yeah, Still significant overhead. All right, let's see how this scales with larger amounts of quantities. Dude, this is so weird. So what? 1 billion. Okay. This should actually spike the editor, I think, a little bit. Hopefully. Okay, cool. 10 job. Oh, yeah. Memory leaks. That's a thing that can happen. Anyways, I'm going to show you something else, too. There's one more layer to this. And I'm kind of curious now how that's going to perform. Maybe because the operation is pretty simple. I don't know. Oh. Oh. Crashed it again. I did it twice. All right. This time for real. That is wild. I just wanted to do a simple little demo to showcase this job system, but now I'm learning, dude, maybe sometimes regular ints are fine. Regular memory arrays are fine. Sometimes. All right, where's the demo? Here we go, demo. We're gonna save it this time, because we mean it. Yeah, save the scene. Yeah, save it. We're just gonna save the scene as is. Yep, save. Yes, I don't care. Cool, cool, cool. Windows. Analysis. Standalone process. Cool. Alright, hopefully we don't break things. We're gonna find out now, dude. We're gonna find out just how much we're gonna learn today, man. All right, before we do more with this though, I want to show one last thing, and then we're gonna just see how everything performs relative to each other. So I mentioned we can treat like this as like the GPU sometimes, where you have tasks happen in parallel. If you look at this task, right, does it matter what the previous iteration, like if you, let's say you're at I equals 10, does it matter, does it affect or the code that executed on I at the value of 9 for I affect 10? And does a 10 affect the values for 11? No. These things can all be applied at the same time. They can all be applied in parallel. So an alternate thing you can do with jobs is have them be done in parallel. And it's very similar to this. Let's say parallel update. And instead of using iJob, you use iJob4. And the method's gonna be a little bit different. You notice how this one says execute with no parameters, but this one actually has an index. So iJob4, you're implementing this specific thing. It's accessing one specific thing from one specific index in an array. And it's cool because instead of this, because with a for loop, it iterates from each element. We're gonna go to 0 and then do stuff here, and then we're gonna go to 1 and do stuff there. This, it executes all at the same time. It does like 0 to whatever range at the same time. And in essence, it kind of acts like a GPU. It's pretty nuts. So this code will translate to like this. In this case, instead of I, it'll be index. And honestly, I feel like you should be able to do this. I don't know why it doesn't let you do that. Yeah, you have to actually, okay, yeah, I remember now. So one new thread doing for loops, 1 second. So it's one new thread doing loops on n threads doing one job. So it's one thread doing for loop or n threads doing one job. I think in effect it's kind of like n threads doing a job. Let me show you the syntax for this. So we're gonna yoink this because it's gonna be very similar. And this one's gonna be job parallel. And then this can be, I don't know, data 2. Yeah, and then job 2. And this is gonna be enemy parallel update instead. You're gonna see though, because you can actually kind of shift and manipulate that. So again, we have this, but now we can't use, we shouldn't be able to use this. This normal scheduler is not gonna work. In fact, if I try compiling with it, it should not allow it. iJob4, my bad, wrong interface. Parallel for. Here we go. And so iJob parallel for interface. And then here is where things get a little bit spicy. So okay, now you're gonna see an error here. And it doesn't like this. This is wrong. You have to use a different way or a different method for scheduling. And it's going to take a parameter. So you specify the length of the array. So in this case, enemies.length. But then here's the interesting parameter. You have this integer value, and it's called inner loop batch count. And this specifies how many iterations of the for loop each like parallel job can execute. So you can have it where each iteration is done in parallel. In this case, like I believe it's an inner loop of 1. But if I set it to 64, this is saying, hey, each parallel one is going to process 64 iterations. So one's going to be doing 0 to 60 to 63, index 0 to 63, and then the next one's going to be from 64 onwards. So you can change this value here. And now this is going to execute a job in parallel. And then, did I never end the sampler? Oh my goodness, dude. I never, that's probably why the, okay, we're going to see how these values have been shifted around. And we're going to make this hopefully not crash. I'm going to lower down the value again. Just to be on the safe side. Because I don't want to keep running Unity. Alright, we're going to run it and we're going to look at the profiler and we're going to see, we're going to find some truth today. We're going to either find some truth and deep insight, or I'm going to be a liar and my pants are going to be on fire. So we're going to run. Run, baby. Run, baby. Okay, and we're going to press space. Hey got printed out. I paused. And let's see the truth. Let's face the truth. Let's see if we can handle the truth. I imagine test is here. And cool, we have our 3 different tests. You have classic, we have job, we have job parallel. And then let's see the timing for this stuff. So yeah, significant overhead still on these. So classic is 136. This is 226 milliseconds and 308 milliseconds. So again, dude, in this specific scenario, this super stripped down example, we're not actually seeing that much. We're not seeing a performance benefit. In fact, it's a performance penalty, probably from job allocation stuff. All right, we're gonna add an extra 0. Just see what happens. Let's see what happens. Either that, or let's just do some crazy operations to make this even more complex. So let's do like some, I don't know. Let's first make a unified function that this is going to be doing. Also, these structs should be outside. Whatever. Who cares? All right, we're going to make a public static int static, or static int expensive process, and we're going to return, I don't know, math f, because really the benefit comes when you're doing like computationally expensive things. Sine f, I don't know, Assign F. Assign within a sign. Math F sign. I don't know. 12.12 F. Why not? Something complex for no good reason. And then maybe throw in a square root in there for fun. Square root. Yeah, because why not? All the kids are doing it. All the cool kids are doing square roots. Expensive operation now. Expensive process. And then here we do equals expensive process. Or I guess in this case it'll be what? Demo dot expensive. Let's move this in here. 1 second, guys. There's a promised land. I promise you. I'm promising you there's a place we're going here with this. Why is this? I'm yoinking this. Okay, these two exist out of here. I'm gonna bring these into the class, or just make this public. In fact, just do that. That's easier. Demo dot expensive operation. Yep. And then here we're gonna do demo dot expensive process. Cool. Now let's see how crazy we get. Let's see how nuts we go. Okay. When I'm in a never end the sampler competition and my opponent is Marco Blue White Eyes, as always, base Unity is so perfectly optimized and no user end optimizations will ever trump Unity's pure baseline. Unity's pure infinite wisdom can never be trumped, guys. All we can try to do is imitate and get close to it. Oh my goodness, why is Rider the thing that pops up? Or not Rider, Lunar Vim. Did it forget my preferences. I can't believe Unity forgot my preferences. This makes me so sad. Alexa, play Despacito. That's an old, gosh, that's an old meme. I'm old. What's happened to us? Okay, there's one too many parentheses here. That's okay. Compile. Okay, we run it. Cool. We're gonna press play. Now we have an actual work being done, not just a single increment. I may just explode my PC. I may have just exploded my PC. Hey, it's done. Okay, let's actually look at the breakdown now. Let's see what the breakdown looks like. Did this capture that? I hope it captured it. I don't see it capturing it. Okay, we're just gonna do that sucker again. One more time. Hit it. 1A. 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 Okay. And then here we go. Here we go. Okay. This is looking like I wanted to show you. There's a purpose to the job system, guys. I promise you. Okay. So classic Unity takes 4,312 milliseconds to process this more computationally expensive job. A job that isn't just incrementing an integer, but actually doing some kind of work in it, right? A normal job takes 304 milliseconds to execute. Just so you can realize, like, this one took 88% of the entire frame time. Unity's basic array managed way of doing things. Using the job, we have 4.7%. And now with the parallel job, there is some benefit there. It's smaller. It's only 220 milliseconds, 4.5%. A big change, a big chunk, well, not between those two. It's actually pretty negligible. But it illustrates the point. Illustrates the point. And you can do different. You can play around with this inner loop value and get different types of results too. But yeah, all this hoopla just to show you that this is what the job system looks like. This is how you make it work. And it's particularly important when you're actually doing real work and not just incrementing a value for whatever reason. So like, you know, I've used it for like physics stuff before, or like processing stuff like movements of a bunch of different entities. Also, what's up, Terrell? New fingies POV. Yeah, we got the fingies exposed. We got the fingies out here, so you can see the starship control happening. All right, DMK. But yes, this is the job system in general. Anytime you're doing some processing, for example, like processing vertices on a mesh. Let's say you have a mesh that has like a bunch of vertices. You got to do something on it. I'm telling you guys, the way it was implemented before with like the out-the-box importer from Unity or from like a publicly available one, right? It would take 5 minutes to process that 3D model. Like I'd start the process and I'd walk away and it'd have to take a couple minutes. Like literally 5 minutes, at least. But then rewriting it with burst compilation in the job system brought it down to like hundreds of milliseconds. It was crazy. It went from something that took 5 minutes to execute to just instantaneously. So yeah, a new tool in your arsenal. So if you're working in Unity and you want to have some performance, and you're doing some kind of crazy computations over a bunch of different things, bam, a tool in your disposal. It's kind of interesting how this guy isn't that crazy. Like I wonder if we do more. I kind of want to learn. I kind of want to go on a little side adventure here because Kieran, you brought up the idea of like you brought up the idea like, oh, it's potentially like multiple iterations per thread. Let's do a comparison. Let's actually do some comparison. I'm gonna yoink this again. Yeah, I'm just gonna yoink this, and this is gonna be 1. And this is going to be 64. So now we're going to schedule. We're going to reallocate some stuff because why not? Why not reallocate? Never hurts to reallocate a little bit. And we're going to change this to be 64 batches instead of 1. Or batch, inner loop of 64. And yeah, no change in code, data 2, job 2, scheduling job 2, but now we're going to use data 2. And this should have been using data 2 as well. Hopefully that didn't change the data 2, the results too much. Whatever, it shouldn't change the results at all. Okay, and yeah, let's just send it. Let's just send it. Ladies and gentlemen, let's just send it. Let's just do a little control P action, little control P. We leaked some data. It doesn't matter. Don't matter. We hit it. We hit it. Let it wait. Let's see. There we go, baby. That's what I'm looking for. Okay, and then what do we got here? Okay, so the batch 64. Interesting. This one's a little slower, guys. Yeah, I think when we put like even more elements, like, because we can't do this with Test Classic with the Unity stuff, because we make it too big, it's just gonna crash. It's not gonna be able to handle it. But these guys, we can push a little bit harder. We can push them a little bit harder. We can go a little bit more spicy with it. Just see how it turns out, you know? Just see what goes on. Yeah, it's pretty cool though. Hope you guys got something from it. DMK, I hope this is cool for you to know and maybe hopefully applicable at some point. We do CUDA optimizations and it's slower than classic. That would be the full circle. That would be the full circle. That would be the full circle. Turns out we should just use Unity arrays. No, here's a big thing, right? So we talked about C++ versus C# and how there's this whole thing called a garbage collection for batch 64. I think it's 0 because we're reusing. So we're using the temp allocator, and that's different than a persistent allocator. Unity has this pre-allocated batch of a memory you can use and work with. So the reason a temp allocator is faster than a persistent allocator is because a persistent allocator goes, oh, you want this amount of data? We're going to go into the heap, or we're going to make that data be available for you so you can use it in your job. Whereas the temp allocator goes, hey, you need to use this for a job? Okay, I'm going to pull from an already pre-allocated thing and use it. If you notice, we're using the same data for both of them. So I'm using data 1 here, and this is using data 2. And we're using the same allocated. Even though this is allocating a new one, this already pre-allocated a native array of that size, and then the job got executed and it finished, and it's disposed with that temp array, I believe. So this already got pulled from there and then released. And then we immediately have another job with the same exact data that it needs. It's already hot in memory, it's inaccessible. So I'm imagining it's not paying that price of doing that. In fact, let's compare between them. But I think that's exactly what's going on here. GC alloc for parallel 64. Yeah, because we pre-did that with parallel 1, I believe. I will rewrite every single thing I've ever programmed to implement Unity jobs. Every single line of code. Everything will be data oriented. We will have dots. I misspelled parallelize. And I still misspelled it. Okay, skill issue. But there's like so many ways you can do this. Because this is one way of doing stuff. If you want to be really, because like, jobs are not, even though you're using this burst compiler and it's compiling native code, like native, it's compiling, like let's say you have an x86 architecture, it's compiling to that, right? But even then, it's like not a perfect process. There might be some cool instruction sets, and this is what I learned today. You may be having some instruction sets that are not being used by this because it's not smart enough to understand that's what you're trying to do. So you can go to like jobs, show timings, open inspector. Let me see if I can find it. Or maybe is it called burst? I don't know. Force on, enable compilation, synchronous compilation, native debug, mode compilation. Burst. No, it's a toggle. There's a way to view the compiled open inspector. Okay, here we go. Here we go. So here you can choose whatever jobs exist in your code base, and then it shows you the different stages of compilation. So here's the assembly code for your specific architecture of your system. In this case, it's going to be x86 code. And you see all the instructions that are being used and how they're self-referencing and how that works, right? And there's times where this is not the best. So like today, there's someone at work who was looking at this because he was suspecting that the generated assembly wasn't producing, it wasn't actually doing some cool vectorization instructions. But yeah, this is another level. If you really want to juice it, you could also write just C++ code, guys. You could write C++ or Rust code if you want to do that, and have it be used in C#. That's a thing you can do. You can use form functions. You can have your code be exported and then ran in here. It's this cool though. You can see the different stages, right? Because you have like the LLVM optimization and then LLVM unoptimized, and then you see the .NET intermediate language. This is where it goes from C# to this intermediate language, and then from there it gets transpiled, or not transpiled, it gets converted into assembly. This is the nice thing that makes it portable, because if you're like on a one system, you might have something different, right? x86 code is not going to look the same as ARM code, and it's not going to look the same as all this other stuff. True. Where's the SIMD? We're not doing any SIMD operations here. It's all simple stuff. Simple computation. Yeah, I could have sworn there was a way to choose which assembler architecture you want to use? I don't know. I'm just a little country boy from the sticks. I don't know nothing about nothing. Yeah, and I really don't know much assembly, man, if I'm gonna be honest with you. I know, like, you move stuff to registers, and you can jump around, and you can find subroutines and stuff like that, but I don't know enough of assembly. But yeah, there you go, guys. There's your little introduction to jobs and all this stuff and how it works. But when you're a C# plan or C++ plan, you don't gotta worry about this stuff. You don't gotta worry about this. This is non-issues. Who wants to have garbage collection anyways? Who wants to do that when you can just malloc? You can just do malloc. You can malloc all over the place. Do a little malloc here and there. Size of, I don't know. What's a struct? Size of mesh ticket. Just leave that. Don't even free it. Leave it in memory. Let it hang out. Treat your memory like a garden. You want to have a bunch of stuff sprinkled around in there. You know? You want to have decorations. Like, would you want to go to... Do you want to be in an empty garden? No. This is a bad garden. We don't want that. What we want to have is have a garden filled with bobs. So many bobs everywhere, allocated, sharding memory. Just, you know, taking up all available space. Yeah, because we're not gonna have a nice array of bobs where they're contiguous in memory. No, we're not going to do that. We're going to have bobs be wherever we want them to be. Here, there, everywhere. Just making your RAM not as useful as it could be. I think this is the way we should be doing things. Just malloc. Just do that all over the place for fun. If you have a job, just do this in your code base. And then there's going to be like some report that says, hey, there's a bunch of memory leaks happening. Why is that happening? I don't know, man. That must have been merged in with that ticket. What was that ticket again? Oh yeah, my job security task. That was the task. That was I keep my job here by introducing bugs. That's my job security ticket. We introduced the bug so I can fix the bugs. Ram the RAM with Bob. RAM unused is RAM wasted. Exactly. Look at this. We're gonna see just how much wasted dedicated RAM. Look at this. Wasted. Look at this. 26 gigs. 67. Someone do some quick math. It's like 40 something gigs. Wasted. We could have made this worse. GPU utilization. Only 30% or 30 something percent. 40 something percent. That's a waste. It should be 100%. It should be maxed out all the time. If it's not being used for something productive, use it to crypto mine. Am I right, guys? Am I right? Let me get a chicken nugget. 1 second. 1 second. I got some leftover Culver's. For those of you who are not from the Midwest, it's a fantastic food place. Classic American food. Oh my goodness. How did we get to this topic? How did we get here? But yeah. If your cursor can still move, we can use more memory. This right here, waste. In fact, this is why I'm using the whole keyboard thing. It's because I want to get rid of the mouse functionality. No mouse functionality at all. None of this. In fact, this is too fast. I want to have a lag from all the resources. Honestly, have you guys seen that meme? If it's cold for you, it's cold for them. Do you know what I'm talking about? Yeah, there's like, if you're cold, they're cold. Let them in. Yeah. This meme. This little meme. Let me just... Yeah, here we go. If you're cold, they're cold. Put them in your... Not in your mouth. I just want to say put them in. Anyways. But I guess it's kind of fitting because it's bugs. What I was going to say, the point here is that... If you're cold, they're cold. So you should download a bunch of malware. Think about it, guys. How much malware is out there on the internet? Cold, alone, abandoned, not using anyone's RAM, not utilizing people's CPUs to do some weird crypto mining operations. They're cold. Bring them into your home. Bring them into your CPU. Okay? Download a little malware. Let's fragment your RAM a little bit. Let's have some bobs everywhere. Ram your RAM with bobs. That's all I'm saying, guys. This is your PSA for today. Download some RAM, add some random malware to your code. Life is going to be good. Life is going to be great. What was that? There's that controversy that happened a while ago. Not controversy. It's not controversial. There was that thing with Mock, I think, or some library, where they had if you use the library, it installed a crypto miner onto your computer. I forgot what it was. Wait. Library installs crypto miner on PC. Nope. Hack. Virus. I forgot. That was a while ago. We need one of those sad dog shelter ads for computer viruses. That's what I'm saying. Like, well, remember when computer viruses were very charismatic? Or was that the purple monkey virus? Like the Y2K viruses are great. Like the Bonzi buddy. Look at this. How can you not invite this guy onto your machine? Nothing wrong here. Nothing suspicious at all. I just see a cuddly friend. I see someone who needs a home. I have a home. He needs a home. It's just a win-win. But yeah, like, I have all the recent, like most viruses you see nowadays, they don't have charisma. They don't have personality. I miss my Y2K viruses where it's like a dude who made this thing, who made a mascot. I miss viruses with mascots. What was the dolphin one? I need to refresh my knowledge. I need more viruses to be aware of for research purposes. Cuz honestly, why would I use my computer to program? Why would I be productive? Why am I wasting my time and energy and skill in life making something that's going to bring joy and happiness and value, maybe even comfort to people, when I could just be making really funny haha viruses that gives me money, maybe. Making a botnet. I could sell that to Russia, dude. It'll be great. Purple is a color of poison or elixir. I don't know. Yeah, but it's so alluring. But here, purple is the color of royalty. Don't forget that. Purple is also the color of royalty. Back in my day, viruses had some character. Now they're all upfront with wanting my personal information. Back in my day, you used to be able to buy games and own them and not have them be taken from you. You guys remember perpetual licenses? Remember when this existed? Remember when this was a thing? Game Maker Studio. Let's see, I don't think they offer it anymore. I think I was like one of the last people who had perpetual licenses. No, I don't want no cookies. No, stop. What do you pay? I want to see Game Maker. Where do you pay for this? Anime Girl. Very cool. Game Maker features. I haven't used Game Maker in forever. I kind of want to download it and try it out for a second. Just to see what I'm missing. Maybe I was wrong, guys. Maybe writing my engine wasn't the right route. Maybe we should be just going back to our roots and going back to Game Maker, programming in GML and having another breakdown and crying when I can't figure out what's going on with my code. Dude, we can be the next Pirate Software, dude. We can use integers instead of bools. It'll be great. It'll be great. We can make unoptimized, like intentionally it'll be great. Like, hey guys, how many, we're gonna set, you know, like when you work in a project, like in a game or something, you might have like a technical budget that defines how much memory are we aiming to use and how much CPU utilization are we aiming to use. What's our budget for that, right? And then we work around that. I want to have a budget as well. It's like for how bad, like what level of bad we want to get to before it becomes unplayable. Like we're gonna have like a 20 FPS budget. Oh, the game is too optimized. It's hitting 120 FPS. We gotta bump that down. We gotta add some for loops in here, dog. Oh baby, add some for loops. Add some for loops. Can I not purchase Game Maker? Can we not purchase? Is this free now? You can download it. All versions of Game Maker are completely free to download. You only need to pay if you plan to release your game. Interesting. Okay. So free to use, non-commercial use. Okay, whatever. Okay, one-time purchase. They have perpetual licenses. For commercial license, GX games, export, desktop, web, mobile. Enterprise is $79 monthly and then that yearly. That's crazy. I remember distinctly Game Maker switched to a subscription service and everyone was pissed off about that. Maybe they listened. Maybe they heard. Maybe they cared. Isn't that heartwarming? Game Maker still cares about the people. Perpetual license still exists. If you just take the word perpetual, remove the letters, and add temporary. We need to add a switch case for every letter of the alphabet when accessing characters and dialogues. We only cater to the GPU rich people. Yeah. We only cater to people with 12 gigabytes of VRAM. And we're not using it for anything productive. We're actually going to be filling it 80% of it with Bob. Like PNGs of Bob. We're just going to add that to memory. And then the rest is actually going to be used by this. What we're gonna do, we're gonna write code that actually queries what GPU you're running, and then as a data table of the specs for it. We're gonna realize, okay, we have like 12 gigabytes to work with here. Now we know we have to waste 11 gigabytes of memory. We have to be the one. We have to be like obsessive girlfriends, who they don't want you looking at anyone else. They just want you looking at them. Like when you play a game. No attention on anything else. No Firefox. No music. No task manager. That's cutting into the budget. That's cutting into the budget. We want your full undivided attention. And if you have to write malware to do it, we will write malware. It's okay. It's okay. We'll write malware. It's okay. It's fine. It's fine, dog. Well, I was thinking about doing something and I forgot what I was planning to do. Yes, kill the processor. Their process. I don't care. What was I thinking right now? Oh yeah. Low-key, so DMK, that little suggestion you said about the alphabet switch statement, we might have to actually do something like that. Because for my engine, I actually want to try to see if I can get away with that, with not using actual proper GUI rendering. Like a GUI library. I wanted everything to be sprite based, which means that fonts have to be sprite based. And I may have to do I'm probably gonna have to end up implementing like a table where we're gonna have like a switch statement that indicates like the x coordinates on the sprite sheet, like the same way we have our animation system. Like if you look at how we do animation, it's not individual sprites, it's actually one big sprite texture sheet, and then all we do in the shader is specify the current index, and it does the math of like figuring out in which coordinate on the x or y are you to offset that fragment, so you're only sampling one part of that. So we're gonna just basically take the same idea and just apply it to a large texture sheet that's just gonna be a font, and then we just manually set the lookup for that. So that's gonna be jank, but I think it's kind of fun to try to do that because we need text at some point. We need to have text. And we also have to do some other stuff. Like I want to have a bar that shows like how much is rendering taking, how much is physics updates taking, what. No window operations. If your computer's trying to run its OS in the background, the app will terminate all your PC's operations. Don't even try doing a system call. Don't even try it. Don't even try it. We'll add a monitor to it, and we'll make sure you can't do that. That's just what we're gonna do. What can I say, man? It's called user experience. It's for their own good. The user doesn't know what they want. They don't know what they need. I know what they need. Yeah, this whole game system, this whole engine is like super scuffed. But it's gonna be broken in a fun way. Like it's gonna be disgusting and weird. It's not meant to be like professional. Or it's professional in one way, I guess, but it's also not in another way. I'm totally not using any of the principles that I've learned. There's a book called Clean Code. I have it right here, I think, actually. Or maybe it's upstairs. Yeah, I have it right here. There's this book called Clean Code or Clean Architecture. And we're not using them. Everything in this book, not really using it, if I'm gonna be honest with you, man. Yeah, like there's a whole component stability formula. Actually, we're kind of using some of that. We're kind of managing relationships with this stuff. There's interesting concepts in here for sure, but yeah, most yeah. We're not making the most use of that. It's okay. Actually, this doesn't even concern clean code because it's just me saying, hey, we're not going to use any sprite UI rendering library to render smooth text. We're just going to do everything through sprites and analysis, and it's going to be fine. We're going to be happy with it. Do you want to implement that now? I don't know. I don't think so. I still want to. This is like I was looking at the Dyson Sphere. This all was started when we were at the Dyson Sphere and looking at how we're gonna design the level to start using to start testing this level editor. Ta-da. Editor changes. Super helpful commit message, man. Super helpful commit message, man. Yeah, guys, I learned Vim, and I have the split keyboard so I can type mistakes even faster. Like, yeah, my words per minute went up, but it's still like a 50% error rate. We haven't improved, really. We only appear to improve because we fail faster. That's what we do. We fail fast. Gosh, how many things I have here? My goodness. Oh yeah! I know what I want to do for the levels. I need to download Blender. That's what I need to do. I need me some Blender. You know what has a perpetual license? Blender. A perpetually free license. Please tell me you work on Linux. Don't do this to me. Please tell me you work. Download Blender 4.4. I'm assuming you work. Windows. Linux, yes. 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 My darling. In a tar format. In a tar format. Oh, why am I doing this? There's Snap, right? Yeah, I could just do this. Whoops. Whoops. Oh, that's kind of awkward. Yeah, I have to type my password, don't I? But I have my fingers being exposed. All right, everyone, we're just gonna use the trust license. we're just close your eyes real quick, guys. I'm gonna type my password, but you guys are totally not gonna peek, right? So just close your eyes and I'm just gonna trust that everyone close their eyes as I type my password I use for absolutely everything. My banking, my life, my work, my everything. Just kidding. We're not gonna do that. We're gonna just turn this off. Webcam. There we go. Now all you have to work with is the sounds of my click-clacking. Try reverse engineering my password from the click-clacks. The click-clacks. I thought I copied this. I'm pretty sure I copied this. Why are you being so difficult? Okay, whatever. Sudo. Okay. Core 200, beautiful. Man, I love how easy it is. All right, fingers back. Fingers back. But yeah, C# is pretty cool. I've thought about maybe even trying to figure out how to do C# interoperability with C++, but I'm really realizing maybe I shouldn't entertain that thought. Maybe we shouldn't play around with that monster. Maybe there is such a thing as biting off more than you can chew. No, I don't know. All right. So we're making a little environment for ourselves. We're white boxing here. We're trying to see how things may or may not be. How things may or may not look. And then we're gonna make sprites for this stuff, and then that's gonna inform our level editor. I need to make enemies too. I need to do, like, there's so much to do. There's so much to do. I have to also prototype some of the gameplay. Because, like, what's the point of pretty environments if the game sucks? In fact, arguably, I probably should be doing that now instead. In fact, maybe I will do that. I will do that. Alright, let me go to Aseprite real quick and make some stuff. So we have this grab mechanic in the game. That's a big thing we're working with. And, like, it's kind of like Min from Smash Brothers. If you ever heard of that little game. Kind of a not popular game, very niche and not heard of, but some people like it, and yeah, we're just gonna be ripping Min's flow beat for beat, bar for bar, cause I think there's a lot to explore there that hasn't quite been explored. Alright, player textures. Arm segment .png. Cool. So we're gonna make even though the player has like their arms like attached to their body, we're gonna make it where when you launch it, you can shoot your arm out and you're gonna see these segments stretch out over a certain space to wherever you're aiming at. And that's gonna be what dictates a lot of this behavior. So let's go to the player class or struct, and we're gonna have to create a couple of different things. I think I even started making some stuff here, if I'm not mistaken. Yeah, we have the arm segments and then hand. That's important. So let's iterate, do this stuff here. For and I equals 0, and then I less than 3, I plus plus, and then we're gonna set this arm segments equal to sprite object I should have a static method, I believe, for create. Yeah, create. Beautiful, beautiful. And we're just gonna use a string for this bad boy. Create what? What do you create? What do you need? You take in session and position and scale and vert shader and fragment shader. All these things, gosh, man. Why are you so needy? So needy. Okay. What else you need? Position. Gosh, Mackie. We should probably how do I want to handle the position? I'll use player position for right now. Or actually, we just have. I just straight up have this value already saved. And then what else do you need, buddy? And then scale. I believe we have that already too. It's gonna be 64 by 64. Or actually, this is did I make it 32 by 32? Perchance, I believe I did. So I make this John 32. This joint. Okay. Create position 32. And I think that's all the arguments that are in there. And then, interesting, we cannot assign access non-static member without an object argument. What? What you talking about, Willis? Access to non-static. Oh, because this takes place in a static gotcha. I gotcha. Samples, super simple. Okay. So now we have our arm segments that kind of exist. I know my code is really small. I should probably size it up just so it's a little visible. Though I'm not sure how much of this. It's whatever. It's whatever. Eyes don't fail me. You can find the edit button and the appearance button. I believe in you. We'll do 100%. Make it a little bit easier on the eyes. Beautiful. Beautiful. Okay, so now we assign the stuff. This sprite object though. Do you not use, we have overloads. Okay, that's cool to have overloads. Do we not set this texture for you? Maybe get a renderer, but we don't assign a texture by default. Interesting. Interesting. Very interesting. Okay, we'll just do that. Player dot arm segments. Oh my goodness. Render. What's going on here? Why are things not making sense to me? There we go. And then set texture. And then we have that. And we have, what else do we need? What other thing we need? Oh yeah, we need a texture info. Ooh. Ooh, oh, 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 oh. That's a thing. Texture, registry. Session. I'm gonna have to rethink this structure because I'm already starting to find some friction here. Get texture. And I can search by name, and I already know the name of this guy, so we're just gonna do it like that. And it's what again? Arm segment.png? Yeah. Arm segment.png. No, not PNG. Arm segment. Okay, so let's assign these elements to the player, and then now we want to have these segments. When the player's idle, these arm segments are just gonna be like, they're not gonna be visible, honestly. But then when the player presses a button, they're gonna shoot out to whatever the current target position is. For our purposes, it'll be like directly in front of the player. And then we'll go from there. I know the rest of the behavior that should happen, but we're just gonna go step by step here. We're just gonna do that. Keep life a little bit simple. And then we need a hand as well. I just need it to be a little bit bigger than the normal ones, and we should be good, I think. Fact. Let's just do this. Okay, can we size uniformly? Can we scale? I'd really like it if we could scale. I don't see a thing for that though. Tragic. Alright, whatever. We just do this. It's fine. It's not the end of the world. I've lived my life drawing circles manually. This shall not kill me. Yeah, we'll worry about the arm attachments and stuff, making things pretty later. We just gotta make it good. Hand. That's all that matters. You need to make it look good. Just make it work first, and then we'll go from there. And then, okay. I'm gonna change this to be like a mutator instead of a static function, or it's gonna be a static function, but it's gonna mutate allocation. Whatever. We're not gonna worry about that. Hand. Very nice. So we got our hand there, and then putting our hand here. It's getting super handsy, man. Just touching things, man. We're gonna end up in HR at this rate. Cool. And let's just add some little code blocks. Arm segments. And then hand. We can make this nice and pretty later. Don't matter. Or at least it doesn't matter too much. And then now we have to update the player state. So now there's a new state. There's not just idle or running or jumping or air. We have to have like retracting or launching and then retracting or flying to it. We're just gonna worry about launching and retracting. Launching and retracting. The two main things of Fire Nations. And we have to update our state machine, our little state transition thing a little bit to support these extra conditions. Generation state, yep. Gotta do them. Gotta have them. Can't live without them. So, oh my goodness. We're gonna do this the way I usually do it. Normally I'd like to use stateless, like in C# land. There's a cool library called stateless that's really nice for creating state machines. However, part of this is just kind of role-playing, being Spartan, using not that much stuff, you know? Just keeping things as minimal as possible, so I'm not looking for a stateless equivalent. I mean, I probably am for the future, but right now we'll just work with what we got right now and go from there. So this is true. You can go from idling to launching. You can't go from idling to retracting, however. That is incorrect. Oh yeah, I do this thing where we just don't fill in the case statements for invalid transitions. It's like idle. This is not going to be. We'd use the default case in this case. And then, yeah, that. Cool. Simplified switch statements. I had to do a K-map today. I haven't done one of those in a minute. It actually wasn't useful. Well, it was kind of useful for organizing my thoughts, or organizing how to use it helped organize like the Boolean logic I was doing, but I really couldn't get a super simplified. I can really simplify the expression more than it already was. But it was nice to verify it using that. I was like, hey, my degree is in handy. I'm using the things I learned in college for something. That's crazy. That's insane. People normally don't do that. I normally don't do that. But today I do. This default case is even more bum, because it's not like, oh, but it can roll off. Ooh. Realizing something bad here. If I just had this like this, oh, but I can just remove the entire statement. Okay, yeah, and then it's gonna go to the default, and then it's gonna get out of here, and it's gonna go down here to just return false. And we can make this switch statement so much more easier. Now we specify the statements that are true, that are valid. That's all we see is the valid transitions. Oh my goodness, this changes everything, man. Freaking out a little bit. I never had it this good. And then generate the missing statements we have here, which is, where's my missing statements? I specifically asked that you generate missing case statements. Okay, here we go. Of course, another switch. And this time it's going to be state, the requested state. In fact, I should probably specify that. State is not very descriptive. This is the requested state we're trying to go to, or seeing if we can transition to. And then we're just saying, hey, you can or you can't do that. Either yeah or nah. So in this case, don't need the default case because it'll fall out and then it'll break, and then life is good. Sweet. And then we got this joint. And then what's a valid transition for error? Errors, I'm not even sure if I'm using error this case at all, so we're gonna ignore it. Requested state for launching. So it's only valid in the cases of, the only valid requested state you can go to from there is retracting. So in the case of retracting, that's valid, that's true. Turn true. Otherwise, everything else is wrong and incorrect, and you should feel bad. I can live with that. And then, so from launching to retracting. Now from retracting, you can go to any statement. You can go to any state you want to, basically. Retracting is it's coming back to you. You threw it out and it's coming back to you. So, honestly. Oh, actually, no. So the one thing we're going to reject is launching. Because you can just, we don't want you to interrupt your current thing you're doing. So everything except launching. So I guess in this case we'd need to have a default case because it's not the regular false default one that we have down there. This is actually a return true. Because everything is, we want to get out of the state of retracting into whatever state is valid. So if you're falling down and it retracts and it finishes, you can go back to falling your jump state or idle state or running state or what have you that you're requesting. Okay, this sounds actually pretty cool, pretty good. Now this is gonna be the tricky thing because we haven't done really that much. We haven't done any kind of asynchronous code, but now we're actually gonna have to do that with a sequence of your arm going out and then your arm coming back in and the player being locked and frozen in place while they're retracting. So that's a whole thing we got to do. So where is our update? This is the request state. Where is the actual state machine? Here we go. Generate, no, not a default case. Missing case statements, yes. And we're gonna make some functions. We're gonna make some methods here. We're gonna have our launch method. We're gonna have our retract method. And create member function. Yes, indubitably, yes. And we also need our declare this guy too. No, not global. I don't want global. I want a member function. Beautiful. Yes. Precisely what the doctor ordered. And now we're gonna go back down here. And we're gonna put this function right here right quick. Yes sirree. Yes sirree, Bob. And now we can start doing this stuff. So we're gonna have some things that are needed here. We need to have, like, let's say a launch interval for how long it's gonna take. That could be a constant, honestly. Const expression. Const float. Launch interval. And it will be in seconds. In sec. And let's say like it takes like I don't know, 0.3 seconds for that sucker to go out. That might be too slow. Maybe like 0.2. That sounds more palatable. And we have to have like a timer, a little accumulator for the elapsed time. Float elapsed time. And I think that's about it. I think that's pretty much everything. And then yeah, I think this is enough to start working with. So we're gonna put our hand. The hand is gonna move out. The hand is gonna be shooting out. So we're gonna lerp from the player's current position to yeah, we're gonna do some lerping. We're gonna do some lerping. That's what we're gonna do. We're gonna do player dot or actually hand dot. No. I know what I want to do. What I really want to do is have this. I know what things we have to do. We have to do elapsed time plus equals time dot or delta time. That's a for sure thing we need. We're gonna have to do some interpolation. So we have to do hand dot transform, and then we have what, our session. Yeah, we're not gonna do this whole thing of like having data pass through functions. I was flirting around with that because I was like, that's kind of cool, and now I just don't like that. I'd rather just have anything, all the things I need to work with available to me at my disposal. So we're gonna have just session data pointer session. Yeah, I know. I'm using a freaking pointer, a raw pointer, man. Scary stuff. It's okay. It's okay, me. This is gonna significantly be outlived by the session. Probably. Probably. Yep, that works. Cool, and then we go back down here. Now we have session available to us. Let me just dereference. We're dereferencing a null pointer, man. Transforms dot set position. And we also have to calculate a p-value. So float p is going to be equal to elapsed time divided by launch intervals second. And then we're going to do this whole lerp business here. Honestly, man, I'm thinking to make this useful, I may just like use this ticket and have these functions built into it. Like, it's using an index, but it still has a pointer to the session thing and then does stuff there. There's stuff I'm thinking about. We're gonna do the current bad way of doing things that I architected terribly, and we're just gonna rock with that for a little bit, and then we're gonna circle back to this join and think about it. We're just gonna do it the wrong way or a bad way, and we're just gonna think about it, see how it makes us feel. Also, I'm pretty sure I had like what, vector utilities? I forgot. Math utilities. I know I did some lerping here on a... Did I just do math lerp? Is that what I did? I didn't do a vector lerp? If so, that would suck. Well, hey, there's at least a class here with some basic stuff. And it has a lerp. Okay, so we found the vector lerp class. Cool. So we have... And... I'm not sure why you're not happy, but I'm assuming this has to do with something else. And... Transform. And then, okay, here we can do our thing. So we have player position. Yeah, we're not gonna do this. We're not gonna do this. We're gonna make life easier on ourselves. We're gonna make life easy. Instead of doing this whole thing, we're just gonna do session transforms. See, easy. Dude, it's like pointers make life easier or something. That's kind of crazy. It's kind of crazy, man. Position And then we have to have our target position. That's the other thing. That's the other thing. So we have to have float 3 target, and that's going to be equal to, we're going to do a little ternary operator here. We're going to do is right, because I believe that's nope, that's something else. iOS base, what is face right? I have a variable called right. Okay, yeah, right. No, that's not right. That's not right. That's not what I'm thinking about. Where are you? Is right. It's a private thing. Of course it is. Oh my goodness. I haven't decided on a naming convention, but whatever. It's fine. So you're facing right. We're going to do your current position. Or position plus, I don't know. Let's do float right 2, right 3. Why are we mad? Why are we mad here? I'm working on it. I'm working on it. Doing my best here. Oh, because it's a function. That's why. Cool. Otherwise, we use left. Okay. So now we have our target, and then we can use target, and then the p-value. And you're still mad at me. Why are you mad at me? What did I do to you to deserve this hatred? Unwarranted hatred. Add template argument list. What? What? What is this? What is going on here? My bad. Didn't mean to have that feedback. Too few template arguments? Oh, is it dimensions? You have to specify the size? Oh. Oh. Okay, this is correct now. This should be correct. Cool, so vector, we're using, is this C-sharp's like standard vector? No, it's math foods vector. Okay, cool, cool, cool. Sweet. Okay, now beautiful. So we should be incrementing like this each frame, and then what do we do from there? And then it goes like that until a certain point, and then we have to also update the segments, the individual segments, so they're spaced out accordingly. So the hand moves out, but we want to have the segments, the little ball segments, be placed accordingly. So we'll also do that. I might want to make just a method for updating that, but we'll do it here first. Int I equals 0, I less than 3, I plus plus, and then we do arms segments. We have to make a new p-value. Hopefully it doesn't overwrite. It doesn't matter if it overwrites it. P-value of what? What do we want our p-value to be? We want our p-value to be I divided by 3, I'm assuming. Probably not, because that's 0 is going to be right over the player, and 3 is going to be right on the hand. No, we want this to be a little bit scrunched. So we're going to do this times, like, I don't know, let's see, 0.8. Yeah, 0.8 plus 0.1. I believe that's what we desire here. I believe this should produce the behavior we desire. And again, we're just gonna do this lerping thing. The same lerp logic here, we're gonna do here. So we're gonna do, but instead of hand, we're gonna do arm segments. Vector 3, lerp position, target P. Beautiful. No, hand. Hand dot transform. Got a scruncher. I am scrunching. Or are you talking about you scrunching? Is something scrunching you? Yeah, I do devolve into the... I devolve into the little shrimp posture. That is a thing that happens to me. Oh man, I need to simplify this stuff and make it easier to use for myself, but it's fine. So we have this, we have for float P, session transforms, subposition, arm segments, I transform. Okay, I think, I believe that this should work in some form or fashion. And then we just have to execute this. That's the other thing. Okay, yeah. So... And the override that's going to happen is if you try... If input that get... Okay... Get is action pressed. We're gonna do the thing. We're gonna do the thing, guys. We're gonna do action 1, and we're gonna set new state equals launch. Rocket launcher. Might talk about the code data, but yeah, got that posture unscrunchied. Yes. I fear. I don't want to end up like the shrimp from whatchamacallit. Shrimpana. Yeah. No. Wait, did I actually show her? No, I just don't. What is? I have not watched Smiling Friends. I'm gonna be honest with you, but yeah, I'm talking about. Talking about this guy here. Talking about this guy. What? No, I just want to see the picture. Here we go. Slowly, the more we work, the more I sit down and do this stuff, this is where we end up. This is where we end up. This is what happens. I just want to make sure our input's correct. No. There we go. Clever girl. And then let's make sure our action's actually correct. So what's our action 1? Did I not even add a binding for that? We would have been pressing the button and nothing would have been happening this entire time. Very scary. Very sad. Alexa. Okay. And this is going to be a simple thing. We're going to do 1. This is going to be... action 1 count, and then we're going to be action 1 binding, and then it's going to be the F key because that's what I'm most used to at this point. And down here we just have to do one last thing, which is just set this bad boy to what? Action 1 binding, and then action 1 action 1 count. What diff between while pressed versus is pressed? While pressed versus is pressed? Do I have something like that? And so there's 3 states. There's pressed, there's is pressed, is released, and is down. The code method function. So there's like, let's go back here. So we have input dot is. So we have these 3. We have is action down, is action pressed, and is action released. So is action press is just the first iteration. So when you press the button down, it's gonna be true that instant. Then if you hold it down, the next frame it'll be false. So this only happens when the button is immediately pressed. Is action down is going to be telling you true every single frame the button's down. So if you're holding it down for 1 second or 1 frame or whatever, it's going to be true for the duration of time you're holding it down. And then is action released only fires when you release the button. So it's not going to fire when you press it, and it's not going to fire when it's held down. It's only going to fire once the button is released. So that's the implementation I did here, and it's kind of mimicking pretty much most code, but honestly most engines do that kind of thing. Unity and GameMaker have their own different ways of doing that. I know in GameMaker it was like VK key down, and then yeah, there's a whole thing. And then in Unity it's just input.get. Yeah, it's like a similar function. It's like a similar syntax as input.get key action or whatever. But yeah, so that's the distinction between those things. And then this is just a way of binding multiple. The reason I use action and not keys is because you might want to have multiple keys perform the same action. Like for example, moving down, you might want to be able to press S, or you might want to press the arrow key down. Both should trigger this action, and you can check to see if this action is being performed. You could make the person be like, hey, is S or down press, but that's just more, it makes the code more verbose. I don't want to deal with that. So having bindings helps make this not as complex to deal with, or makes not the code not as crazy to deal with. Get action. Key and set. Yeah, press release, and then we have other thing for managing this stuff. And I think one last thing we have to do here. Action 1. Why are we mad? Oh yeah, because I have to update this guy to be 6. We have 6 key bindings now. For left, down, up, enter, editor, and action 1. Beautiful. And then I believe, if I'm not mistaken, things went wrong. What happened here? What happened here? Why are you mad at me? Oh, it's because I made things simpler. That's a first. Things broke because I made things easier. That's thankfully easy to work with, I think. Easy to fix, I believe. Why are we mad here? What did I do? Attempted to use deleted player operator. What do you mean deleted player operator? What are you talking about? What are you talking about? Deleted player operator. I didn't delete no. Is it because I added a pointer? Is it because I added a pointer instead of a reference? Wow. Your mother. Okay, are we fine now? No, we're still not happy. Oh my goodness. They're calling the Sentinels on me. The name is Gambit. Remember it. I can't, dude. I'm still kind of mad. I'm just mad how Gambit got done. Like, his death was cool. Sacrifice is awesome. We'll always remember it. For Rogue, that lady. She did my boy dirty. She did my boy so dirty. Code Corpus Most Wanted, man. They're after me. They're after my split keys. It's not me. It's actually the split keys. This is not a skill. You're not seeing me being skillful. You're just watching a man be hard carried. By his equipment. Yeah, what is going on here? What seems to be the issue, officer? Position, session. Why are you saying attempting to use a deleted operator? What are you saying, you crazy person? You crazy guy, man. Crazy dude, man. What do you mean with these words? Deleted operator. What do you mean, man? A constant variable? Oh. I was being clever. I use a const variable. It's supposed to be static. Const expression. Oh my goodness. Hopefully that fixed stuff. Yeah, it did fix that. That was the problem. I was just dumb. Okay, things are broken. I see the things here. I see the balls. But I'm pressing things and things aren't working. Things aren't working as intended. I'm a little concerned why things aren't working the way I intend them to. I use the key F for key action count 1. Ooh. Action count 1. Also, this is using down count. What am I doing, dude? Enter editor. Buffoonery. Maybe this is bad code. Maybe I just did bad code. Maybe these mistakes are due to me writing bad and unscalable code. Not reusable code. Hard coding stuff. Maybe I'm just a bad programmer, dude. Maybe that's just the thing. Maybe I'm just bad. In fact, no. I am bad. That's just what it is. Oh, let me also, like, not have this be running at 6,000 frames per second. That might be also good to do. Yeah, let's bind this back to 60 frames per second. Yeah, no. We want to have something reasonable. The right key isn't working anymore. Huh. I've either done something dumb or I've done something dumb. Those are the only two options. I did something dumb in the player or I did something dumb in the inputs. Either or, one or the other. Nope, we have right and left. Right is specifically what's not working. And this behaves, it seems to be fine. Seems to be fine. Is action pressed? Okay, let's see. I probably did something dumb here. So left down, right up. Okay, binding 6. We have a left count. We have a right. Binding, right count, yep. 3, yep. Up count, up bindings, yep. Down count, makes sense to me. I don't see anything wrong here. Enter editor count, that's 1. Editor binding, actual binding, okay. If you go down here, left, right, up, down. We're using the appropriate counts, so I don't see any issues there. Enter editor binding, yes. And then input action binding, also yes. So what is the deal with that? What is the deal here, officer? I'm using the correct key, GLFW key F. Oh my goodness. Broke his left leg. Yeah, his leg's not working. He can't move. Can't move in that direction. You done broke it. Oh, let me try arrow keys. Let me try the arrow keys. Arrow keys work. Oh. Oh, we did some weird shenanigans. So F key, wrong key. I was supposed to be using J. First of all, that's that. The arrow keys worked fine. I don't know why D didn't work. Let's try this again. No, so the arrow key works. It's just the D key is not working. What is going on? And then if I press F, the game crashes. So let's run in debug mode. Let's run a little debug mode and then to see where things went wrong. Where was the seg fault? Where was the seg fault? I ran in debug mode. You're supposed to tell me. You're supposed to show me these things. You're supposed to show me the world, man. 4, 5, 6, 7. Oh, I didn't. Oh. Oh. Jump key and I have my bindings messed up. That's the first thing. My bindings are in the incorrect order. It's supposed to match this, so it's supposed to be like left, down, right, up, jump, which we don't have here. We should probably add it. Jump. Or actually, I should really just do the way it's formatted currently, where there's no jump, and we just have this start at 4, and this is 5, and then this is 6, and now that matches here. Yeah, I did some done stuff. What's the deal with airline controls? There we go. And it still crashed. Could we please have the debugger at least catch when we do wrong things? Because at least if it's seg faults, it tells me where is the wrong thing. Could not render GL error. Well, gee, thanks, man. I would like to know where the GL... Oh, it's not seg faulting. It's actually... I'm catching it. I'm just not... Ow. I want to play Peak again, man. That was fun. I can't get over it. That was super fun. Dude. Peak was super fun. I enjoyed it. I enjoyed Peak. That was super dynamic. Super emotional. Highs and lows. Many lows. But some highs. But many lows. Oh my, it's almost 4 a.m. Alright. I was gonna play some games, but I should probably sleep. thank you guys for hanging out. I appreciate the company as I dig through code and cover the job system and all this other fun, weird, jank stuff. Yeah, guys. Another day and more progress. We'll make a game at some point. At some point, we're gonna be making a game. That's gonna happen. Did you learn of the event? No, I did not learn of the event. I should Google it though. I'll probably Google it before I go to sleep. That sounds like a great move. That sounds like the move I should be doing. So we're gonna do that. I'm gonna end stream. I'm gonna Google the event, and then I'm gonna sleep soundly. That's what I'm gonna do. That sounds like a perfect recipe for success. All right. Well, thanks for hanging out. I appreciate it. I'm gonna try to. We're gonna spice some things up. I want to play some games or something on stream instead of just working. But yeah, I'll catch you later. Until next time.